Hello everyone, welcome to mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics, Paper 5, which is the Probability and Statistics 1 for October-November 2020, and the code is 9709/52. So let's move on to question number 1. Question number 1. A fair six-sided die with faces marked 1, 2, 3, 4, 5, 6 is thrown repeatedly until a 4 is obtained. So when until a 4 is obtained, that means this is geometric distributed. Okay, now A, find the probability that obtaining a 4 requires fewer than 6 throws. So less than 6 throws means that maximum 5 throws to get a 4. Okay, so now the probability of getting a 4 is 1/6 because it's mentioned fair six-sided dice. So which means my P is 1/6, therefore probability of failure is 5/6. Now, you need to calculate probability that less than 6 throws. So your x is the number of throws. Less than 6, that means it will be at least 5. Okay, less than 6 means that at most 5. Okay, maximum 5. Now, to get this, I have a formula. Whenever x is geometric distributed with P, probability of success P. Now, probability of x less equals to small x, it will be 1 minus q to the power of x. Okay, so now when you compare, that means my lowercase letter x here is same as 5. So it will be 1 minus q is 5/6. Then with degree 5. So when you calculate, this will be 4651 over 7776. So now we have a round up to 3 significant figures. That will be 0.598. So that's the probability of A. Now, on another occasion, the die is thrown 10 times. So B, find the probability that a 4 is obtained at least 3 times. So when consider 10 times, that means this becomes binomial. Okay, so x is binomial distributed with 10, with n is 10, and then the p is 1/6, because you need to get a 4. Alright, so our formula, x is binomial distributed with n and p. So probability of x equals to ncx px qn minus x. Okay, so that means from here, my p remains as 1/6. So then my q will be 5/6. So now at least 3 times. So it means px greater equals to 3. So greater equals to 3, if you need to direct calculate, you have to calculate a lot. That means it's from 3, 4 until 10. So it's a lot to be calculated. Therefore, I'm going to use the complementation rule. We know that total probabilities is 1. So I use 1 minus all previous. All previous x means that 0 until 2. So I minus all this total. That will be the requested probability. So from here, I will get 1 minus x equals to 0 means no success. No success means all are failures. So probability of failures 5/6. And I have thrown 10 times. So all 10 times will be failures. And then px equals to 1 means that 10c1. Okay, so 1 success and 9 failures. Plus, out of 10, 2 successes. So probability of success is 1/6. And then probability of failures will be 8 of them. So then from here, when you calculate the numbers inside the brackets, it will be 0.77523. Then when I minus, I will get 0.22477. And now I round up to 3 significant figures. So by looking at the 7 here, the fourth significant figures, so you have to round up the 4. So I'll get 0.225. That's the solution of part B. Okay, now next question number 2. A bag contains 5 red balls and 3 blue balls. Sadie takes 3 balls as random from the bag without replacement. So without replacement means that you will not put it back after you have drawn first ball and followed by second ball. Now the random variable x represents the number of red balls that she takes. A, show that the probability that Sadie takes exactly 1 red ball is 15/56. So from here, okay, so you need to calculate P1 red, but then we know that she takes 3 balls. So exactly 1 red ball means that it will be another 2 blue balls. Alright. So from here, I will say that it is 1 red, so 5. Initially you have 5. So 5, choose 1, followed by another 3 blue balls, you choose 2. Okay, over total 8 balls here. So 8 balls, I choose 3. Okay, then from here you are getting 15/56. Right, when it is without replacement, you can just use C because you won't be getting the same ball. Okay, so that's the solution of this question. Okay, now part B, draw up the probability distribution table for X. So here we have solved 1R because your X is the red balls. So now I just need to calculate when no red ball and 3 red balls. So now when Px equals to 0, that means all 3 blue balls, right? That is, now you have 5 red, 3 blue. So 5 red, 3 blue, and now you take 3 blue balls. That means it's 3C3 over 8C3. Then you will be getting 1/56. Now, when Px equals to 3, Px equals to 3 means all 3 red balls. All 3 red balls, simple, 5C3 over 8C3. So that is 10/56. So now you need to draw up the table. Okay, so this is the probability distribution, X values. Px equals to lowercase letter x. Your x is 0, which is 1/56. X is 1, already counted just now, which is 15/56. So x equals to 2, leave it first. X equals to 3, we know that it is 10/56. That means from here, Px equals to 2 is basically 1 minus the other 3 probabilities. So I will just show it here. So then you will be getting 30/56. Okay, so that's the solution of this question. This is the table that you need to find. Now, part C, given Ex is 15/8, find the variance X. So to get variance X, we need to get the Ex squared first. So what to do? Just square the X. The formula is summation X squared times P. So I square the X, 0 square, first probability 1/56, then 15/56. plus 2 squared, 30 over 56, then 10 over 56. So from here, you will be getting 225 over 56. So then variance x equals to ex squared minus square of the ex. So here I will get 225 over 56 minus square of 15 over 8. Then here you will be getting 225 over 448. And now you round up to 3 significant figures, that is 0.502. So that's the solution of this question. Now, question number 3. Pia runs 2 km every day and her times in minutes are normally distributed with mean 10.1 and standard deviation 1.3. So now x is normally distributed. That means x is the time. So here 10.1 and 1.3 squared. Because our normal distribution always mu and sigma square. Sigma square is the variance, and now you are given standard deviation 1.3. Therefore, square of standard deviation will be variance. Now, find the probability on a particular day. PR takes longer than 11.3 minutes to run 2 km. So Px greater than 11.3. So now, when you need to standardize this, it will be z equals to x minus mu over sigma. Okay, so then here I will get Pz more than 11.3 minus the mu is 10.1 over sigma is 1.3. Then from here I will get greater than z greater than 0.923. Once you get this, sketch a graph. Okay, middle is 0. So mark 0.923 on the right side of 0, and then the region is greater than. Okay, therefore it's from the line towards right side. But then when you refer to the table always show you less. That means I have to use total probability 1 minus Pz less than 0.923. So this is 1 minus Pz less than 0.923. Okay, and then get the probability from the table. Then you will be getting 0.8220, and at last that is 0.178. Okay, now B. On 75% of days, PR takes longer than t minutes to run 2 kilometers. Find the value of t. So Px longer than t minutes is 0.75 because 75%. So from here, I standardize it. So it becomes z more than t minus the mean. Mean is 10.1, standard deviation 1.3. So minus 10.1 over 1.3. That is 0.75. Okay, so from here, now I need to draw the graph. Okay, you have two choices for this line, either on the left side or on the right side. So if you are not sure where is the line, just draw 2 first. Then because of greater than means from the line towards right side. Okay, so 0.75, or the other one is here, 0.75. So now for your information, the graph is symmetrical at 0. That means supposedly greater than 0, the probability is 0.5. So from here, when you compare, it looks like the green color is not reasonable because the region is smaller than half of the graph. Therefore, I have to erase the green region. So the green region is not the correct answer. So correct answer should be the orange region. Okay, so since the region is the orange color, obviously this is negative value, then I need to reflect it to be positive. So once I reflect it, it becomes negative of the existing value. And then for the region wise, it will be the major region. That means it will be towards left side. Okay, so from here I will say PZ less than negative of t minus 10.1 over 1.3. It is 0.75. Now, this 0.75 is available in the table. So now you just check the normal table. So from table, PZ less than 0.674 equals to 0.75. Then now you just compare. Okay, so negative value equals to 0.674. So here I will just write, so negative t minus 10.1 over 1.3 equals to 0.674. Then now to get the t, this negative 1.3 I combine together and move to right side, becomes times. So I will get t minus 10.1 equals to negative 1.3 multiplied with 0.674. Then here, at last your t, just move this negative 10.1 to the other side, it becomes positive. Then minus 1.3 times 0.674. And then at last, you will be getting 9.2238. And now, we need to round up the answer correct to 3 significant figures. That is 9.22. So that's the t value. Okay, see, on how many days in a period of 90 days would you expect PR to take between 8.9 and 11.3 minutes to run 2 kilometers? So before you get the number of days, you need to get the probability that X between 8.9 and 11.3, because that probability means per day, right? In a day, what is the probability? Then only you get that probability multiplied with this 90 days to get the number of days. Right, so that's the idea to solve this question. So it's between 8.9 and 11.3. So now again you standardize it before you read the table. So minus 10.1 over 1.3 less than z less than 11.3 minus 10.1 over 1.3. Then from here, when you calculate, it will be negative 0.923. And then the other value is 0.923. Okay, so now you sketch a graph, one negative and one positive. So negative 0.923 and 0.923. So the region is bounded by these two lines. So for calculating this probability, I can just flip this negative part to the right side. So that means it's double of the orange region. Okay, so it will be double of orange region. The orange region is basically from 0 to 0.923. So in order to get that probability, I will just say it is PZ less than 0.923 minus PZ less than 0. Okay, so that means this is double of PZ less than 0.923 minus PZ less than 0. And then the first probability you can get from the table, that is 0.8220, and less than 0 we know that it is half of the graph, therefore 0.5 probability. And now you will get 0.644. Okay, this is for 1 day. Now you are given 90 days. Out of 90 days, how many days will be running in taking this time to run 2 kilometers? So now number of days, it will be 90 times 0.644. So then from here, you will be getting 57.96, and I round up, it will be almost 58 days. Okay, so that's the solution of this question. Now, next question, number 4. In a certain country, the weather each day is classified as a fine or rainy. The probability that a fine day is followed by a fine day is 0.75, and the probability that a rainy day is followed by a fine day is 0.4. Now, the probability that it is fine on 1st April is 0.8. The tree diagram below shows the possibilities for the weather on 1st April and 2nd April. A completes the tree diagram to show the probabilities. Okay, so now this is a tree diagram. Just need to label the tree diagrams. So it's mentioned that on the 1st April, it is a fine day with probability of 0.8. So this is 0.8, and the rainy day will be 1 minus 0.8, which is 0.2. Now, and in the question is mentioned that a fine day followed by another fine day, which is 0.75. So here fine day, another fine day is 0.75, and the total of these two branches is 1. So therefore the rainy day is 0.25. Okay, now then the probability that a rainy day followed by a fine day is 0.4. So here is rainy day followed by fine day is 0.4. So then the other one is 0.6. So the total is 1. So that's all for the tree diagram. Okay, now B, find the probability that 2nd April is a fine day. So fine day is because of the previous day was fine day or rainy day. So it means you just multiply 0.8 with 0.75, or all is plus 0.2 multiply with 0.4. So now my probability equals to 0.8 times 0.75, all is plus 0.2 times 0.4. Then now here you will be getting 0.868. Okay, let X be the events that 1st April is fine and Y is the events that 3rd April is rainy. Now find the value of Px intersect Y. So Px intersect Y means that, okay, now it could be X is fine day, okay, then the middle one, because this is 1st April, this is 3rd April. So what happened to the 2nd April? The 2nd April can be a fine day, okay, 2nd April, or all is plus. Remember, all is plus. This is all. The second day can be a rainy day. Okay, so now I need to extend this because my concern is 3rd day, okay, is a rainy day. So now I need to extend this. So when I extend this, right, so here fine day, rainy, fine, rainy, fine, rainy, and then here fine and rainy day. So now remember, we need rainy day here and fine day, right? Fine and rainy. Okay, so fine and rainy, then here fine and rainy. So basically this part's no need, right? So what to do is just label. You see, if fine day followed by another fine day is 0.75. So here fine followed by another fine is 0.75. So which means the rainy day is 0.25. Okay, then now just previous day, rainy day. Okay, rainy day followed by fine day is 0.4. So here 0.4 and this is 0.6. So now here I just need to get these two probabilities. So which means 0.8 times 0.75 times 0.25. That is fine day for the second day. Right, so I will just write it here. 0.8. This is 0.8 times 0.75 times 0.25. All is plus. Okay, Friday 0.8. Rainy day for the second day, that is 0.25. Then times 0.6. Then this is going to be 0.27. Okay, now D, find the probability that 1st April is fine, given that 3rd April is rainy day. So 1st April just now X. 3rd April, because of given that this is conditional probability, given that's Y. So from here I will write Px intersects Y over Py. This is the definition for the conditional probability. So X intersect Y means that 1st April is fine, 3rd April is rainy day. That means that is the solution for part C, which is 0.27. Okay, over PY. PY means 3rd day, 3rd April is rainy day. So if 3rd April is rainy day, then you have to consider, right? Now I have to check here. This is the 3rd April. So now I have to complete these 2 branches. So from here, find day, find and find 0.75. So here 0.25, rainy and find 0.4. Then here 0.6. And now it's mentioned the 3rd day is 3rd April is rainy day. Okay, 3rd April is rainy day means that now I have to add 2 more. Okay, so just multiply, right? So then I will get, I copy these 2, right? So 0.8 times 0.75 times 0.25 plus 0.8 times 0.25 plus times 0.6. Then I need to add 2 more. So the other 2 will be rainy day, fine day, and rainy day. So 0.2, 0.4, 0.25. Plus last one, it will be rainy day, rainy day, rainy day. 0.2, 0.6, 0.6. So from here, you will get 0.27 over 0.15 plus 0.12 plus 0.02 plus 0.072. Then you will be getting 0.27 over 0.362, which is 0.746. So that's the solution of this question. Okay, question number 5. The following table shows the weekly snowfall in centimeters for 11 weeks in 2018 at 2 ski resorts, Dados and Linva. Okay, represent the following information in a back-to-back stem and leaf diagram. So first of all, right, let's look at the smallest value, 0. For Linva, 0 is smallest, biggest is 40. For Dados, smallest is 6, biggest is 42. Okay, so now I will write here Dados and Linva. Since smallest is 0, so I start with 0. Then biggest is 42. So 1, 2, 3, 4. Alright, so now start labeling. So for dados, 1 digits, 6 and 8. Then I have 2 tens, so I will write 0. Okay, after that I have 12, 15, 16. 2, 5, 6. Then 22, 28. After that 36, 42. So for Linois, smallest is 0 and then followed by 2. So 0, 2, because the first one is basically the ones. Okay, then after that 9. So 10, 11, 12. Followed by 15, 16. Okay, then there's no 20s. So 32, 36. After that 40. Now for the stand and leaf diagram, do not forget to write down the key. So key, let's say I take this 632. This means, okay, look at the question, centimeters, right? This is the snowfall, so in centimeters. So that means 36 centimeter snow in Dados. Then 32 centimeters snow in Linhua. Right, so that's the solution of this part A. Now B, find the median and interquartile range for the weekly snowfall in Dados. Alright, now Dados. So here we know that it will be 11 weeks, therefore 11 data here. So median is half of 11 plus 1. This is the position. So you will get 6. Data number 6. That is the median. So now look at the stand and leaf diagram. So this is data 1, 2, 3, 4, 5, 6. That means the answer is 15. So here I will write equals to 15. Now interquartile range. Interquartile range we need to get Q1 and Q3. So interquartile range that is Q3 minus Q1. So for the Q3, okay, so now I will label. Since we know that this is median, right? This is median. That means you will have 5 data on the left side and 5 data on the right side. So when you consider median of the first half, okay, first half. So which means you just divide equally here 2 and 2. This is the median of the first half. That means this is Q1. Alright, and then for the median of the second half. So here 1, 2. This is 1, 2. Sorry, 1, 2. So that means this is Q3. We divide equally. So Q3 is 22, Q1 is 10. Wait, let me check. Okay, you check from using this method. This is let's say I use another color. I use this. Okay, this is first, second, and then this is third. Right? From the biggest value. This is 4th, this is 5. Right? So my Q3 is the middle of the second half. So middle means that it will be number 3, right? Because this is the greatest, this is second greatest, this is the third greatest. So that means my Q3 is 28, my Q1 is 10. So means that now my interquartile range is 28 minus 10. That is 18. Okay, now the median, lower quartile, and upper quartile for weekly snowfall for Linhua are given this. So that means this is Q2 median, then Q1 and Q3. Use this information and your answers to Part B to compare the central tendency and spread of the weekly snowfall in Datos and Linhua. Okay, so Linhua Q2 equals to 12. Q1 is 9. Q3 is 32. So for Dados, I will list down first so that I can see clearly. Q2 median is 15. Q1 I will get 10 and then 28. Q3 is 28. Okay, so when you compare the central tendency, right? So central tendency means that it is median. Okay, central tendency we refer to median. So this one is Q2. So you can just say the snowfall in Dados plus Q2 is higher, right? Which is 15 compared to Linhua, which is only 12. Okay, then for the spread we will refer to the interquartile range. So interquartile range for Linhua, it will be Q3 minus Q1. So that becomes 32 minus 9, and I will get 23. Okay, for Dados, it's only 28. Oh, sorry, it's only 18. Right, so from here, that means the spread for the Linhua's snowfall is bigger. So from here, I will just say the amount of snowfall in Linhua varies more. Okay, varies more than in Dados because of the interquartile range due to bigger interquartile range. Okay, so that's the solution of this question. Okay, now question number 6. Mr. and Mrs. Ahmed with their 2 children and Mr. and Mrs. Barker with their 3 children are visiting an activity center together. They will divide into groups for some of the activities. A, in how many ways can the 9 people be divided into a group of 6 and a group of 3? Okay, so basically there are a total of 9 people, So now first group 6%, second group 3%. That means it will be just 9, choose 6, and 3, choose 3. Because after you have chosen 6 from the 9, left another 3. So the other 3 automatically will be in one group. So this is 84. Okay. Now, 5 of the people are selected as random for a particular activity. Find the probability that this group of 5 people consists of all 3 of Becker's children. Okay, so now I will write down. So Mr. and Mrs. Ahmed plus 2 children. Okay, and then Mr. and Mrs. Becker or Becker plus 3 children. Okay, now you need 5 people. Then from here there are 9. I need 5. These 5 consists of Mr. and Mrs. All 3 of Becker's children. So 3 Becker's children. Okay, so another 2 will be others. Alright, so from here, my probability, it will be 3 Becker's children, you choose 3. Okay, so 3 choose 3. And now remember, there are total of 9. Okay, total of 9. So since you have chosen 3, so that means here no more 9, left 6. So from this 6, we need to choose another 2. Okay, so it will be times 6, choose 2. Since this is probability, now you have to divide by number of selection. Selection will be 9%, choose any 5. So then this is going to be 15 over 126. And at last, it will be 5 over 42. So that's the solution of this question. Okay, now next part. All 9 people stand in a line. Part C. Find the number of different arrangements in which Mr. Ahmed is not standing next to Mr. Barker. Okay, so now let's say Mr. Ahmed and Mr. Barker are not standing next to each other. That means now you will have, okay, Ahmed is A. Let's say, for example, I label, okay, now this Mr. Ahmed is A, Mr. Barker is B, okay, then the wife, WA, and then WB, and then I have CA1, and then CA2 for the 2 children, and then here I will have the CB1, CB2, CB3. Okay, so let's say Ahmed is A, okay, and then wife A, CA1, CA2. C means children. Okay, then I have Barker B, then WB, W means wife. Okay, A means Ahmed, Mr. Ahmed. Then B means Mr. Barker. Then the children, CB1, there are 3 children here. CB2, CB3. Okay, A and B are not standing together. Means that I will arrange the rest. So, means that I will arrange WA, CA1, CA2, then WB, CB1, CB2, CB3. So, from here, basically you are arranging 1, 2, 3, 4, 5, 6, 7. So I arrange this 7% first. That means it will be 7 factorial. Okay, followed by arranging Ahmed and Barker. So now, for Ahmed and Barker, I have few choices. So it can be in any of the arrows for the A and B. Okay, so it means that now I have 1, 2, 3, 4, 5, 6, 7, 8. 8 arrows. So 8 positions for Mr. Ahmed and Mr. Bakar. So 8. But I need to choose 2. And after I have chosen 2, I need to arrange, because it can be the first one for Ahmed and the second one for Ahmed. So means that it is HP2. Okay, then that means this is 282240. So HP2 is to arrange. This one is to arrange Mr. Ahmed and Mr. Bakar. Alright, so that's the working for this question. Or probably you can use another method, means that you arrange all first, then you minus, they are next to each other. Okay, so another method is you arrange all, means 9 factorial, minus when they are together. So when they are together means that it will be like this. So here A and B together, then you have 7 left. So it means that now this 7 together with this, it becomes 8. So it will be 8 factorial, but then A and B can swap. So times 2 factorial. Okay, so let's check whether you get the same answer or not. It will be 362880 minus 8 factorial times 2. 80640. Then here you will get 282240. Same answer. Okay, so you have 2 choices for the working. Now, next question, D. Find the number of different arrangements in which there is exactly one person between Mr. Ahmed and Mr. Bakar. So, let's say here is A, then one person, and this is B. Okay, so since there are 9 persons in total, here can be 6. So this is only one way. Alright, so then from here, to make sure there's one person in between, I will group A and B together with the middle value, middle person. So 6 plus this, one group, it becomes 7 person. So after that, right, 7 factorial. Then from here, I know that to get this person, right, initially 9 person. This 9 person, it consists of A and B. Then you have 6 others. So now I know that I have to choose one person to be placed in between A and B. That means I have to choose from the 7 others. Okay, so from here I choose 1. So which means 7 choose 1. This 7 choose 1 is for the middle value. Okay, middle selections, the middle person. And then after that, the A and B can swap. That means it could be B, A, then middle value. So that means I have to times 2, because the times 2 factorial is to swap the A and B. So this is to swap A and B. It can be AB and it can be BA. Okay, this 7C1 is for the middle person. Alright, therefore, the final answer here is going to be 70560. Okay, so I have completed the whole paper, and it also comes to the end of the video. Thanks for watching. Please subscribe to the channel and share this channel to your friends if you enjoy watching the videos. Right, so and also stay tuned for more upcoming videos. Thank you. Bye.